Hey guys, so this is the last video of review before we actually get into chapter 4. So we need to talk about exactly parallel and perpendicular lines. In the last video, we just did a refresher on linear equations and graphing them, finding the slope, writing the equations. Now let's focus on parallel and perpendicular lines. So parallel lines, first of all, the symbol is like that, two little L's. So if you see me do that, that means parallel lines. Parallel lines, they look like this. They have the same slope and they never intersect. They go on forever and they never intersect. So slopes of parallel lines, if two non-vertical lines are parallel, so that if they're non-vertical, that means they're horizontal. And if they're horizontal, then their slopes are the same. Or it doesn't mean they have to be horizontal. They could go like this too. They just have to be then the same. Any two vertical lines, so if we do have vertical lines, or any two horizontal lines are parallel. Okay, so really that top one didn't have anything to do with horizontal lines, more just non-vertical. It could be horizontal. What we want to practice is writing, is figuring out, are two lines parallel? So it says line L contains these 2 points, and line M contains these 2 points. Are lines L and M parallel? What we need to do to test if lines are parallel is we need to determine slopes. So we're going to use that equation we refreshed our memories on in the last video and find the slope of each line. Let's label. I've got x1, y1, x2, y2. So I'm going to do 2 minus 6 over -1 minus -13. 2 minus 6 gives me -4. -1 minus -13 is really plus 13. That gives me 12. -4 over 12 simplifies to -1/3. That's the slope of line L. So I put M and a little L next to it because that's the slope of line L. Now we're going to go find the slope of M, line M. Let's label again, x1, y1, x2, y2. So I'll have 7 minus 6 over 6 minus 3. And I get 7 minus 6 is 1, 6 minus 3 is 3. This is my slope for line M. So are these lines parallel? Remember, parallel lines have the same slope. This slope is -1/3. This slope is +1/3. So we can say no, L and M are not parallel because slopes are not the same. Next, we need to be able to find the equation of the line parallel to this line that contains this point. So what we need to do here, guys, is, first of all, if we're writing an equation of a line that's parallel, that means the slopes are going to be the same. So what is the slope of this line? It's -1, and it passes through this point. And we have to realize what we're given. I'm given a slope, and I'm given a point. When I'm given a slope and a point, or a point and a slope, we're going to use point-slope form to write the equation. And I'm going to plug in what we know. Notice I changed that to +5 because it was minus and -5. Then we need to distribute, and then add the 3 over to get the y by itself. And there's the equation of the line. Next, let's talk about perpendicular lines. So perpendicular lines, the symbol is an upside down T. So if you see that, that's perpendicular. They have negative reciprocal slopes. So let's talk about what that means. Negative. So another word for that is opposite reciprocals. I like a little bit better because it's just talking about the signs are different. So one's going to be positive and one's going to be negative. That's what negative means. Reciprocal is when we flip the fraction. So 3/4, the reciprocal is 4/3. Or 5/2, the reciprocal is 2/5. So if we have negative reciprocals, if one's negative, the other's positive. Or if one's positive, the other's negative. And perpendicular lines, they intersect, and they intersect at right angles. So these are all right angles. If two non-vertical lines are perpendicular, then the product of their slopes is -1. So if you multiply these together, we get -1. Same thing here. Numbers with a product of -1 are opposite or negative reciprocals. I like the word opposite better, you'll see. Because opposite is referring to signs, being opposite signs. And any one horizontal line and one vertical line are perpendicular. And that makes sense. Because if I have a horizontal line and then a vertical line, they intersect at 90 degrees. So again, let's check. If line M contains these points and line N contains these points, are these lines perpendicular? We've got to check the slopes. Again, we're going to use our equation. And we'll label our points. Whoops. X1 and Y1, X2 and Y2. So then I've got -1 minus 7 over 3 minus 2. -1 minus 7 is -8. 3 minus 2 is 1. My slope is -8 of line M. And then here we'll label again. X1, Y1, X2, Y2. M equals 7 minus 6 over 8 minus -2. 7 minus 6 is 1. 8 minus -2 is really 8 plus 2. I've got 10. This is my slope for line N. Do we have perpendicular lines? This slope is -8. This is 1/10. And they need to be negative reciprocals. And we can say no. M and N are not perpendicular. They do not have opposite reciprocal slopes. Okay, let's try another one, problem 6. Line F has these 2 points, line G has these 2 points. Are they perpendicular lines? We'll label, and we'll plug into our formula. Is that 7? Y2 minus Y1. I did 6 minus 7. Oh, 6 minus 7 over -6 minus 2. I get -1 over -8. So my slope is 1/8 for F. And then for G, I get x1, y1, x2, y2. 11 minus 3 over 4 minus 5. I get 8 over -1, which is -8. So looking at these slopes, 1/8 and -8, we can say yes, F is perpendicular to G because they are 1/8 and -8 are opposite reciprocals. If you flip them, remember every whole number is over 1. They're opposites, right? 1 over 8, 8 over 1, one's positive, one's negative, so they're opposites. And then problem 7, find the equation of the line perpendicular to this equation that contains this point. So again, we need our slope. And our slope's -3, but the slope of the equation that's perpendicular is going to be 1/3. Remember, you flip it and change the opposite sign. And then we're going to use this point, x1 and y1, and we're going to go right into point slope form. we're going to substitute in y1 is 7, and our slope is 1/3, and x1 is -3. And then we can distribute the 1/3. 1/3 times 3 is 1, and then we'll add the 7 to get the y alone. Okay, and then the last one, you guys can check this, determine which of the lines below are parallel and perpendicular. So remember, we need to look for the slopes. Here, we know my slope is -1/2, and I've got to solve each of these for y so I can find the slopes. If I look at line 2, let's solve this one for y. I'm going to subtract the 4, and I get y equals -2x minus 4, which means my slope is a -2. And then let's look at 3. It's 2x minus 2y equals 12. Solve for y. I'll subtract the 2x over. And then I'm going to divide by -2 by everything to get the y alone. -2 divided by -2 is just a 1. 12 divided by -2 is -6. Look at my slope, it's a 1. So are any of them parallel? Do any of them have the same slopes? No, right? None are parallel. None have the same slopes. What about perpendicular? Do any of them have opposite reciprocal slopes? Notice these two are reciprocals, but they're not opposite. So none are perpendicular. Okay, guys, that is our review. Oh, wait, I've got one more section. Oh, look at this. Graphing linear equations. To graph a linear equation, we've got some steps here. First thing we need to do is rearrange the equation into slope-intercept form. Which is y equals mx plus b. Then we need to determine what the y-intercept is, plot that, and then we need to use the slope. And we kind of just did this. We're going to solve this for y, so I'm going to subtract the 3x over, and then I'm going to divide the -2 by everything. And then here I can see my slope is 3/2, and then my y-intercept is -6. So I go -6, and then I use my rise over run. Rise 3, run 2. On this last one, we can distribute the 3, and then add the 2 over to get that y alone. So I can see my slope is 3, my y-intercept is 5. Throw that y-intercept on the graph, and then I use the slope rise 3, 2, 3, run 1. Okay, good job, guys. That is our last review of skills before we get into chapter 4. Awesome work.